Steel is the backbone of our modern world, shaping skyscrapers, bridges, and even the tools in our hands. But have you ever wondered, how do we transform raw rocks from the earth into the marvel of engineering known as steel? Today, we are diving into the science behind steel, from ore to structure. Get ready for a journey through chemistry, physics, and cutting-edge technology. Before we get started, hit the like button and subscribe to stay updated on groundbreaking insights into material science and engineering. Let's unravel the secrets of steel together. Steel is an alloy primarily made of iron and carbon, but its properties are customizable with other elements like manganese, chromium, and nickel. These variations create everything from rust-resistant stainless steel to ultra-strong construction steel. For example, take the Eiffel Tower, originally made of wrought iron. It demonstrates how early materials inspired modern structural engineering. The journey begins from iron ore, mined from deep within the earth. This ore is rich in hematite or magnetite, which are crushed, screened, and washed to remove impurities. Next, it's ready for the blast furnace. Did you know that the largest open-pit iron mine is over 5 kilometers wide? That is enough to fit over 600 football fields. In a blast furnace, iron ore is combined with coke, a form of carbon, and limestone. At temperatures exceeding 2000 degrees Celsius, iron is reduced, separating the metal from oxygen. The molten iron collects at the bottom, while impurities from slag floating to the top. This is where material science shines. By controlling the carbon content, we determine the steel's hardness, ductility, and tensile strength, key properties for applications like automotive frames and pipelines. Refining removes excess carbon and adds alloys like chromium for corrosion resistance or nickel for toughness. This is also where materials engineers push boundaries to create new steel grades tailored for extreme environments. Aerospace engineers use high-strength, lightweight steel for jet engines to handle both the heat and stress of flight. If you are fascinated by the transformation of materials, share this video with a friend who loves engineering as much as you do. Once refined, molten steel is cast into slabs, billets, or blooms. These forms are further processed through rolling, forging, or extrusion, depending on the application. It's here that precision engineering creates everything from surgical tools to massive suspension bridges. The Brooklyn Bridge is a true reflection of the strength and ductility of steel, holding up for over 140 years and counting. Materials scientists are revolutionizing steel production with green technology, including hydrogen reduction to minimize carbon-4 emissions and additive manufacturing to design complex geometries. Imagine a future where entire skyscrapers are 3D printed with high-performance steel. From raw ore to resilient structures, steel embodies the pinnacle of human innovation and engineering. But this is just the beginning. Material science holds infinite possibilities. Don't forget to like, share, and subscribe for more content that bridges the gap between science and engineering. Let's explore the world of materials together.